Welcome to week 7 of our Python bootcamp. Today we'll be continuing our schedule, and we'll be starting some advanced programming. All right, so first let's just review some things about the final project. So I've seen in the chat some people said that for the most part, everyone said their final project is going well. We probably don't have to spend too much time on this since everyone's project is going pretty well. If you're having any problems with anything, feel free to ask. Also, during this session, if you have any questions, instead of stopping and waiting for people to ask questions like before, just go ahead and ask your question even while I'm talking. So that way we can get to it more efficiently. All right, so for the final project, keep in mind you can also use outside sources, not including this class. So that includes books and websites. You can use any kind of tutorials online. Just make sure you don't copy and paste anything. There are several different libraries. So plagiarism in programming is a big issue as of right now. So imagine if you were trying to look up like a function, right? Let's say maybe you wanted to find out how to sum a row in a list in Python. Then maybe that would be something you could Google up or look up on the internet. And then you could find, basic functions like the sum function. And then you could say, oh, hey, what's the sum function? Let's read about it. And then read about it, and then you can use something like this. So this would be an example of something that is a valid use of your resources. But if you wanted to do something like if you wanted to say like copy and paste this program, then that could count as plagiarism. So take note of that. Also, we're on week 7, so that means there are 2 more sessions. Just as let's take a poll. Type in 1 in the chat if you actually went ahead and you did Google Kickstart like I suggested. So Google Kickstart, remember, it was a programming competition. Let's see. It's a programming competition held by Google, and it's annual. And here we have round E, which is coming up soon, or not soon, but it's in about a month. So the last one was, what was it? Go to the archive. Let's see. So I think the last one was round D. So round D, who actually went ahead and attempted round D? It's okay if you did and you got a low score or anything like that. Just say in the chat if you actually tried it out. Type in a 1. Okay, so not many people attempted round D, but that's okay. We'll just try to attempt programming competitions like this in the future. Remember, the prize for Google Kickstart is a job interview at Google. So especially if you're looking for a job in the workforce, or maybe you want to add something to your resume or anything like that, if you want to win, or if you just want to win the prize, then you can go ahead and try it out. There are some good prizes for that competition. Okay. So last time we ended off on this slide, I believe. But I don't think we had enough time to finish it. So let's take some time to go over all of these different functions. So recall that this function is to represent, both of these functions are to represent the class or the object as a string. And then these functions are also very trivial, or actually I should say these 5 functions. So we have add, sub, mul, trueDiv, and pow. So what these functions do is they actually they're actually very trivial when you think about it. So in Python, when we want to add 2 numbers, we'd say 1 plus 2, right? So really simple, like that. But what if you wanted to make an object and you wanted the object to work so you could add two objects. So like that, right? So like this. Well, how could you do that? You could do that using the this add function. So let's make a class, or I think we had a class from before. Let's see. Okay, I think this was the one from before. Is that correct? I think so. Okay. So here we have our rectangular prism. We have our class method there. So let's add a, let's try the first one. So the first one, the first method that we could try is let's try the add method. So let's add that like this. And then there's a self and other. So self, comma, other. So self would be the variable name of this object, would represent the object, and then other would be the other object that you're adding this object to. So if I was doing 1 plus 2, then, and this was the object, this could be represented as self, and then the other one could be represented as the other. Okay, so hopefully that makes sense. Let's try it out now. Okay, so let's say to add, so our class is rectangular prisms. So to add two rectangular prisms, maybe we could be adding maybe we're adding the volume. Okay, so let's see how we could add the volume of these two rectangular prisms. So this, let's take the volume. So this is how we calculate the volume, right? And then let's add this to the volume of the other rectangular prism. So other dot, and then the width of the other rectangular prism times the height and the length. So I'll just copy and paste. Okay, so like that. So does everyone understand this? So now I could just type in, so let's make a rectangular prism object. So everyone remembers how to do that. We could just, we just have to follow this init function. So let's call it R1 is equal to a rectangular prism, like this. And then we have the height, width, length, and color. Okay, so we already have, we got this here. So let's make the first rectangular prism have a height of maybe like 10, width of like 12, length of maybe 5 or something. And then maybe the color is going to be something like red. Okay, so let's make a second one. Let's call it R2. And maybe this one has, let's just change these numbers a little bit. Okay, maybe this one's blue. Okay, so now let's print out. Do we have a, okay, great. So let's print out the sum of these rectangles. So let's say R1 plus R2. And let's see what that gives us. Oops, I forgot the colon. Remember, because this is a function, in Python syntax, we need a colon at the end. Okay, so the sum of these rectangles, okay, so this line which says, circle object at that, that's because of our print statement from the last class. Let's just comment that out so we can just see this. And yeah, it gives us the sum of the volumes of these two rectangular prisms. Okay, and then the rest should be pretty intuitive, right? So sub subtracts them, mul multiplies them, true div divides them, and pow raises them to the power. So if I was doing, let's just do them all really quickly. So for sub, you would be subtracting these two. So like that. So remember, the whole point of doing that is that now you can really easily represent these two, this equation just with the numerical operators. So yeah, here I subtracted their volumes, and then you can, let's try the true div and divide the volumes like that. Divide this. Okay. Okay, if someone has a question, Google says you have to be at least 16 years old to join Kickstarter. Yes, that is true. But if you find if you know a grown-up or someone that is 16 years old, you could try to register on their behalf, or you could have them register and then just help them with the problems, since now you know Python. So that way you can still get that experience, even if you're below the age of 16. Okay, so we divided them. Let's do the pow. So power operator like this. So remember, the power operator is this, and I'm not paying attention to order of operations or anything, so that could affect all of these answers as well. Whoops. So now notice we don't have the true div function anymore because I just replaced it with the pow function. So now if I did this, it won't work. But since we have the power function, it will work for this. So now we can raise it to the power. And yeah, that's kind of the whole use of that. So then we have the len. In case you're wondering what len is, this is for length. Remember, recall that when we're finding length, I'll open a new Python. So does anyone remember what does the len function do? Okay, well, the len function just finds the length. Should be pretty simple, right? So if I have a string and maybe it's like ABCD, right? Then the len function will tell me how long this string is, like that. So the string has a length of 4 because it's 4 letters. So if I do len and then the string, I'll get this 4 here. So if I did, let's take this, right? So we have, okay, so let's change it to len because we're doing the len function. And remember, we have to take in the right arguments. So here we're just taking in self, like that. And then, so in this function, now we have to define how we would return the length of this. Okay, so let's, maybe we could represent the length of a rectangular prism by finding maybe, I don't know, we could do something like the diagonal, finding the diagonals between, or the length of the diagonal from one corner to another corner. But then again, that would be, we'd have to, you'd have to specify, it would be unclear which corners we'd be referring to and things of that nature. How about we keep it really simple and say for the length, we're just going to represent that by adding the length of all of the vertices. So a rectangular prism has it has 12 vertices, right? Right. Yeah. So let's just add the length of all those vertices. So we have the length, and then we have the width, and then we have the height, like that, right? So here we have these three, And then let's multiply this by 4. So times 4, like that. So this would give us the length of all the sum of the length of all the vertices, right? So now if I did something, now let's do len of R1, like this. And this should give us the length, the sum of the length of all the vertices. So yeah, there it is. Okay, so let's go to the next one. We have get item. This is like if you're trying to recall in dictionaries when you're trying to get the item given a key and then you return something else. That would be it would be unusual to do that for a rectangular prism, so we'll just skip over that. And this is contains. So remember, in Python, if we're trying to find if something contains something else, like let's say we have a list, and this list has a bunch of strings, so A, and then maybe there's the string B, string C, or B, and on the side, string B. So if we wanted to find if there's a certain string in this, we could say S, maybe we're trying to find if the string S is in this list. We could say S in this, and then this would return true or false depending if the string S is in this list. And it's not in this list, so we get false. So that's the point of the contains method. Okay. So self would represent the actual object, and item would represent the this object you're checking for membership in. Okay, so hopefully that makes sense. So remember, this is just continuation from last class since we ended a little early. So next is very important. This is inheritance. So to discuss inheritance, let's go to Microsoft Paint to best, so we can draw it out for you guys. Okay, so we just created a rectangular prism, right? So to represent that, I'll maybe draw, args. Yes, okay, we can discuss args as well. Let's go ahead and do that right now, you know? Okay, so args, when we say the keyword args, if we define a function, right? So let's say we have a function in this rectangular prism. Let's call it maybe f. And then if we want to just take in an arbitrary amount of arguments, like this, and then we could, to represent those arguments, we'd type in the word args, like this. And this would represent all of the arguments you type in this function as a tuple, a tuple. Okay? So if I said, let's keep things simple, let's do it in our Python CLI. So let's create a function called f, and f can take in as many arguments as the person wants to put in, right? So it can take in any number of arguments. And then we're just going to print out the arguments that f takes in, like that. So all this function does is it will just print out whatever you type in into the parentheses. So now if I did f, and then in the parentheses I typed in, I don't know, maybe like 1, 2. So I can type in as many of these arguments as I want. So normally remember before, we'd specify how many arguments. So here there are 4 arguments. Here we can let's type in, we never specified the arguments. So we can type in as many as we want. So maybe like, I don't know, 5, maybe, let's do 7, just arbitrarily. So now what this function will do is it will print out the arguments that we typed in. So here there are 7 arguments. So we got a tuple of length 7 with all of the arguments as an element in this tuple. Okay, so did everyone understand this? Okay. Looks like everyone understood. So no one said they didn't. So now let's continue on to inheritance. So can anyone tell me in the chat, what does inheritance mean? What does this word inheritance mean? Okay, some people said it to earn, something that keeps going. Yeah, that sounds pretty accurate. So inheritance is when something gets passed on to something else, right? So something else inherits like an upper parent or something like that. So maybe if you had a person who was going to so I know that they have like wills and things like that. So when someone passes away, they will pass on their will or their inheritance to someone else, like their money or their house and things of that nature. So inheritance is something that's being passed on to something else. Just keep that in mind for this purpose. So to explain inheritance, here we have a, let's say that this is a, I'll type in, maybe this is our rectangular prism. Oops. Make the font smaller. Okay, so let's say that this represents the class we made over here with the rectangular prism. But also remember, there are also other things that are very much related to rectangular prisms, right? Can someone name one of them? What is something that is very, very similar to a rectangular prism? Yeah, square. That's correct. So when people, maybe you've heard in your math class that a rectangle isn't a square, but a square is a rectangle. So when people say that, what they mean is this. So a rectangle is just a shape that has 4 sides, 4 right angles, and is enclosed like this. 4 sides, and the opposite sides are equal length. And a square, when you think about it, it's really just the same thing as a rectangle, right? It has 4 sides, and it has 4 right angles. So when you think about it, a square is just a rectangle. And just like that, we used a rectangular prism for one of our examples. And when you think about it, a cube, I know some people in the chat are saying cube. Yeah, a cube could be classified as a rectangular prism. So in a sense, what we'd say in Python is if we were to create a class called cube, so I'll type in cube, like that. So cube is a rectangular prism. And we can actually do that in Python. If we created a new class called cube, let's create a new class and let's call it cube. And let's make cube inherit the rectangular prism features. So here we have, so to do that, we need to type in the other class. So if we were going to say a cube, we could say, we type in rectangular, rectangular, these parentheses like this. And so now this would inherit the methods of the rectangular prism. So we'd have the, so let's create an initialize, an init method like this, right? Align to the spacing. And now let's try using it. So instead of this, let's use a cube. and see what it does. So note that this, whoops, this was R1, do R2. Okay, so this is a cube, right? And note that in the cube class, all we did was just define the init function, right? But here, we use the len function as well. And the len function is not defined. The len function looks like this, right? But it's not defined in this, in the cube class. That's because we say the cube class inherits this function from the rectangular prism class. So when I do that picture, the rectangular prism class's data is passed down to the cube class. So that way you can create sort of like a hierarchy. So maybe you were trying to make, maybe for your final project, right? Maybe for your final project you were making a game. Let's say that in your game you created like a player class, right? So your game has this player class, okay? So you made it a class called players, and this player class can do these different functions, but then maybe there are different kinds of players. Like maybe one of the players in your game is like maybe the banker, like if it's Monopoly or something. I know that they have a player called the banker, or they also have another one, or maybe it could be something else, like maybe it's the a landowner or something like that, right? You'd have these different kinds of objects that inherit the values of this thing, right? But maybe you're thinking, well, what's the point? What's the point of all of this? If it can inherit the values of that, what's the point of just making a copy and changing the name? Well, you can also change more to that. Like maybe for this class, we'd add something like, I don't know. You could add something special. Like maybe you could say roll, like maybe this cube is a dice or something. And maybe let's call it dice roll, like that. And then let's just return. Let's import random. So remember, random is how we can do random values. Okay, someone has a question. Calculator. For your project, if you made, okay, so someone made multiple different projects, you can, I'd say maybe try to put all of those projects in one program. So maybe you could ask the user, which game do you want to play? We have these games available. So, you know, something like a menu. Type in which game you want to play, and then maybe they type in the game, and then that's the game that starts running. And maybe they're playing that game. Okay, so, you know, you can do whatever you want for your final projects. These are just suggestions. It's really open-ended. Okay, so for this, let's say we're returning a random number between 1 and 6. Yeah, 1 and 6, like this. So now this special method is in the cube class. Okay, so notice that we added it to the cube class. So now if I called this method on the cube class, so R2 is a cube. So if I did R2.roll like that, it would give me a random number, or dice roll. Whoops. Dice roll. Like that. Now it will give me a random number between 1 and 6. It will do this function, perform this function. Okay. And so now that this is, but keep in mind that this is in the cube class. But if I try doing it on the rectangular prism class, it doesn't work, because in our inheritance, where is it gone? Let's get back. So it's the cube that is inheriting the methods of the rectangular prism. But the rectangular prism isn't inheriting the methods of the cube. So notice the arrow is only going in one direction. So all of the functions, so this rectangular prism, maybe it had like a area function, right? Maybe it had a color, or right, and all of that, right? So it passes all of these values to the cube class. But then the cube class also has this something called a roll, right? We added a dice roll method. So now this roll, now all of these, so all of these values here will get passed on to the cube class. And then the cube class will have everything that's passed down to it, and it will have everything that we added onto it. So you can add these special features onto it. So remember when I said, oh, whoops, I can't go back. Anyways, if you had like a player class, and then you had these, like maybe one of the players a monster, one is a dragon or something like that, one is a banker, one is a landowner, maybe you could give different methods to the banker. Like maybe you could say, well, maybe they'd all share some similar methods, right? Like maybe they can all roll the dice, and maybe they can all move, but maybe the banker has some special methods which which only it can do. So maybe it can, it has a method called calculate money or something like that. And then maybe the landowner has some special methods that only it can do. So maybe something like renting or something. So, you know, that's what inheritance is. And there's also a there's also a way of checking for inheritance, a method called is subclass. But for the sake of time, we're not gonna go into that right now. Okay, so now that was some continuation from last class. So now let's get into our first step of advanced programming, which is called recursion. Okay, so to understand recursion, let's take a look at this comic. So to look at this comic, I'll save to the heap. Okay. So let's take a look at this comic. Great. So first we have a lady, and she's calling Blake. She's saying, hey, Blake, want to have lunch? And then Blake says, would love that, but I want to check with Cynthia. And then so Blake calls Cynthia, hey, Cynthia, want to have lunch? And then Cynthia says, would love that, but want to check with Danny. So then Cynthia calls Danny, hey, Danny, want to have lunch? And then Danny says, would love that, but want to check with Amelia. And then Danny says, hey, Amelia, want to have lunch? And then she says, sure, see you in 10. So then Danny calls back Cynthia and says, sure, see you in 9. And then Cynthia calls Blake, sure, see you in 8. And then Blake calls, I don't really think she had a name in the comic, but anyways, he says, sure, see you in 7. And then later in lunch, they all arrived in the order that they wanted to go in. Okay, so this was just to give a perspective of what recursion is. Let's, to show you recursion, let's Google recursion, what recursion is. Okay, so it says, did you mean recursion? Yes, we did. Did you mean recursion? Yep. Okay, so this is actually a common joke by Google. Recursion, when you type in recursion onto Google, the developers made this as a joke. I will say, did you mean recursion? And then you can keep on clicking that, even though it's the same thing. Okay, so what recursion is in mathematics is a repeated application of a recursive procedure or definition. So this will make a lot more sense on the next slide. Let's go there. So it's a function that goes into a stack, what's called a stack. So if you think about it, like what a card stack is, you have one card at the top, another card at the bottom, and then so on. And then it has what's called a base case to end itself. So if we had a function called recur, which is a recursive function, what it does is it will call itself. So here we have the function recur, and at the end, we're calling the function again inside the function. So we have a function called recur, and then we're calling the function recur in the function recur. Okay, so let's walk through it. So to give you, to hopefully make this make sense, let's copy and paste this, this function into my Python CLI. Okay, maybe I have to type this. So def recur, and maybe this takes an x, like that. Oops. Okay. I was just adjusting so I can see the chat in case anyone has questions while I'm typing. Okay, so def recur, and then next we're printing out x. So print x like that. Okay, and then next we have what our base case. So our base case is like what we have to end this recursive call, which will make sense in a few minutes. So our base case is if x is less than 10, like that. And then if x is less than 10, then we return x. Return x. Okay, and now we're doing what we call the recursive call. So the recursive call is when we call the function, when the function calls itself. So let's say return recur, and then x minus 2. Okay, so here's the recursive function we just made, and it's called recur. So let's try it out. Let's put in a number. Maybe let's try, I don't know, 15. Okay, so we have 15, 13, 11, 9, and 9. Okay, so let's get an idea of how this would work. So we pass in the number 15 into this function called recur, and then we print out 15. So here we printed out 15. Okay, so after we printed out 15, we check, is 15 less than 10? 15 is not less than 10. So then we skipped this. We skip this entire line, and then we go to this line. Okay, so so then this line says, okay, we want to return recur of 15 minus 2. Okay, so 15 minus 2 is 13. So to find out what we're returning here, we're going to pass in the number 13 into this function. So then this function says, okay, so we want to find out this value of 13 and then return that. So 13, when we pass in 13 here, it prints out 13. So here we printed out 13. And then if 13 is less than 10, which it's not, so we're going to skip this line. And then we return recur of 13 minus 2. And then 13 minus 2 is 11. So we're going to go through this function again. 11 is passed in. We print out 11. Here it is. If 11 is less than 10, it's not. So we skip this line. And then we return 11, recursive of 11 minus 2. So then 11 minus 2 is 9. So we pass in 9 into this function. We print out 9, right? So here we print out 9. If 9 is less than 10, yes, it is less than 10. So now we return 9. Okay. So once we return 9, then it goes back to here, and here we return 9, and then it goes back up the stack. Okay. So maybe how many people understood that explanation? We can do another one if you didn't. Okay, so type in the number 1 if you understood that, and type in the number 0 if you didn't understand. And you want another explanation. Okay, so a lot of people didn't respond. Some people understood, but since some people didn't respond, we're going to just do an explanation in pain. Okay. So let's say we have a box. Okay. Or no, let's not do that. Let's use this to draw a box. Okay. So let's say we have this box. And in this box, all we're doing is we are, when we pass in a number into this box, then it will come out as a number that is maybe this blocks is maybe what this box does is it adds 2 to the number, so 2. Make this bigger. Okay, so maybe this box, when it takes in a number, it will add 2, and then return that number with 2 added to it. Okay, so but what if we were to put in another box inside this? So inside this box here, let's say we were to, let's say we were adding a smaller box inside, right? And this smaller box is also just adding 2. So plus 2, like that. Okay. And then when we pass in a number to the smaller box, then it will add 2 to that, and then it will pass that number to the bigger box, and then the bigger box will add 2 to that, and then it will pass out that number as the answer. So in a sense, this is what's called a stack. So here we're stacking a value, right? And so inside the stack, there's a smaller function, or the same function but at a lower level, and then we slowly go up to a higher level function. So let's go back to the picture. Did I close it? I guess I closed it. Anyway, let's open it again. So here we have it open. Okay, so let's zoom into it. So here, I don't remember their names, so let's just call them by their shirt color. So here we have yellow, and then here we have red. So when red calls blue, blue tries to find out if he can fulfill the answer to red. To find the answer, well, okay, so red asks blue a question, right? And then blue doesn't know the answer to the question, so he asks orange. Orange doesn't know the answer to blue's question, so orange asks a question to green. And then green doesn't know the answer to orange's question, so then green asks a question to yellow. But yellow knows the answer, so then yellow gives the answer to green. Green is able to give the answer to orange. Orange is able to give the answer to blue, and then blue gives the answer to red. Okay, so so this is what's called a stack. So at the top of the stack, we have a large upper level sort of function, and then to find what this function, or to complete running this function, the function has to ask a question to itself, and then when it asks a question to itself, the function that it calls asks another question. Okay, so to show you how this looks like, let's go to our JGrass IDE to try and represent this. So let's create a function. Let's call it recur. And let's say n. And so and then in this function, we are going to make it recursive, we're going to call the function itself. So n, when we're calling the function itself, maybe we are calling n-1 this time, passing n-1 as an argument. And in recursive functions, you usually always need a base case, or you need a base case if you want to leave a function. So look at what happens if I didn't have a base case, right? Or let's type this in my Python interpreter, like that. And then if I said return, return, okay, let's just say return. So it's returning a none type. Okay. So what would happen if I passed in the value recur and then maybe like 2? Can anyone guess what would happen? What might happen if I did this recursive function? Just give a guess. It would return the value 1. It returns 1. Okay. Okay, wait, let's okay, well actually it won't return 1. So what happens here is, okay, I'll run it to show you. So here we got a recursion error, maximum recursion depth exceeded. That's what it says. That's because it means my computer doesn't have enough memory to make a stack that fits this function. Okay, so let's walk through the function. So here we have the number 2. Okay, so we pass in the number 2 into this function, and then it says, okay, so recur, and then pass in 1 into the function. So then we pass in the number 1 into this function, and then it says recur, but pass in the number 0 into the function. So then we pass in the number 0 into the function, and then it says recur. We want a recursive call again, but this time pass in the number -1. So then we pass in the number -1. It says we want a recursive call again, but this time pass in the number -2, right? So you can see that there's no end to this. This is just going to go on forever, right? And usually before, yeah, there's no end. There's no end to this. So, but the computer doesn't really have a way of sensing that. So the way it's able to, I got this error was because it actually ran out of memory when it tried to create a stack that was large enough for this function. So that's why we have what's called a base case. So a base case is just a way of breaking out of the function. So if I had this recursive function again, what was it? Recur. I could say something like if. Oops, I didn't mean to do that. Let's see. So a base case could be something that it's just a condition that if the condition is met, then we go back up the stack. So maybe this condition is if I is less than, or maybe if n is less than 2, right? If n is less than 2, then we just return 0 or something, right? And then else, we return recur of n minus 1. So so now we have a base case. If n is less than 2, then we're going to stop recursively calling this function. And we're just going to return 0. So now let's run this function. Okay, so recur, and then let's type in 10. That. Okay, so we return 0. So to show the recursive, you know what? Let's just copy this and paste it. Okay. Okay, so like that, right? So to show you this, let's print out n. So every time we recursively call, before we're going to print out what the number or what the value of n is. So for every recursive call, whoops, let's get rid of that. And then let's call this function. So print recur, and then let's put in 10. There it is. Like that. Okay. So what happens first is we get the number 10. 10 is passed in. Is 10 less than 2? It's not. So then we're going to print out 10. And then we call this function again, except this time we call it with the number 9. So then we say, is 9 less than 2? No, it's not. We skip this. We print out 9. There it is. And then we return the value of this function, except this time it has the value of 8. So then it says, is 8 less than 2? It's not. So then we print out the value of, we print out 8, and then we try it again with 7. And we do this until we are finally less than 2. So then we get 0. 0, once we're finally less than 2, we print out 0. We return 0, right? And that's when we print out the value at the end, once it finally satisfies the base condition. So the base condition is just a way to stop you from running into this error of maximum recursion depth. Okay, so does everyone understand that? Okay, so there's no end. Someone has a question. There's no end, so it says error. How did it work before? I'm confused. Okay, so it worked before. When I did this, right, there was no base case. There's no base case here. So when I ran 2, it said, okay, so 2 minus 1 is 1. But we want to calculate what is 2 minus 1. What is this line here? So to calculate what this line here is, Python runs this function again, right? And then it says, okay, so last time we had 2, but this time we're going to call the same function again, except instead of passing in 2, we're going to pass in 2 minus 1. So now we're going to find out what this, so now Python wants to find out what is the value of if I passed in the number 1 in here. So if you passed in the number 1, then we want to find out what is the value, what would happen if I passed in 0. So that's what Python is doing here. It's not returning, it's never going to reach this return statement here. Before, we had a base case, right? We said if x is less than 10, then we return x. Here, we're not checking the value of n. There's no base case here. That's why there are 2 lines. That's why we're just recurring here. There's no base case. That's why we ran out of memory, and then we got this error here. Since there's no base case, this function will just keep on calling itself, and it will never end, right? So when the function calls itself, you want to make sure that you always have a base case, so then you don't run into this problem. Okay, great. So did everyone understand this? Does everyone understand what the fundamental concept of recursion is? So what does everyone understand what recursion is? Okay, if you didn't understand, just type in 0 or something. There's no shame if you don't understand. Okay, so nobody said they didn't understand. So since everyone feels confident, we are going to go on and try a challenge. So this challenge is to make a function that takes in a number n, and it returns the sum of the first n numbers in the Fibonacci sequence. You may use as many helper functions in your program as you want. And in case you're wondering what the Fibonacci sequence is it's a sequence of numbers, and that is the sum of the previous 2 numbers. So it starts off with 0 and 1, And then to find the next number, we add the numbers, the last two numbers. So 0 plus 1 is 1. And then to find the next number, we add the previous two numbers. So 1 plus 1 is 2. To find the next one, we add the previous numbers. 1 plus 2 is 3, and so on. Okay. So what this function does is it will find the sum of the previous two numbers. And then you want to make a new function that returns the sum of the first n numbers in the Fibonacci sequence. So if you so it takes in an argument n, and then it returns the sum of the first n numbers in the Fibonacci sequence. So if I typed in 4, then it would return the sum of the first 4 numbers. So go to this link, tinyurl.com/recurchallenge, and go to Google Colab or your IDE or whatever you were using, or whatever you want to use for Python for this class when you're running Python, and then try to submit your answers there. We'll take a few minutes, about 5 minutes. I would also like to mention that in case you are not trying this problem, I highly recommend you do attempt it, because I will be giving out points to people that try this problem. So even if you get it wrong, as long as you attempt it, you'll get some points. If you get it correct, then you'll get a lot of points for this problem. That's why it's a challenge. So be sure to try it out in the next few minutes. Don't feel obliged to comment your code for extra points in this, because we're not going to spend too much time. We're not going to spend more than, you don't have too much time to make comments and everything like that. So just focus on entering your code, and you'll get a lot of points if you get this correct. now have about 3 minutes left, so try to wrap it up. If you're struggling with recursion, you can also try to do it without recursion as well. And it arguably might be harder without using recursion, but do whatever you think is best. But just a reminder, about 3 minutes left. Okay, so I see that one person submitted it, but I forgot to add the name keyword in the form. So whoever submitted their answer to the problem, please refresh and submit the same answer again, but this time add your name so we can give you points. So let's give another 60 seconds.
Changes.
Okay, so we gave a little bit more than 5 minutes, so hopefully you were able to answer. So let's take a look at the responses. Wow, we got a great healthy number of responses. Remember, if you even if you don't think you had a correct answer, just try to respond. Try to respond like maybe right now, so you can still get some credit. So let's look at let's try each of these. Okay, so let's look at the first one. We have this, or you know what, I think we could probably we'll actually send the responses or the credit. We'll update our honor roll to do the credit since we're over time. For now, let's just I'll just walk through the answer, some possible answers you could have typed in the next few minutes. I know we're over time, but just hang on so you can understand what the correct answer for this was. So first, let's create a new Python file. Let's create a function called fib. And so we'll take in a number n, and then we're going to add our base cases. So if n is equal to 0, then let's return 0. And then if n is equal to 1, then let's return 1. Okay, so these are just, wait. So if you didn't submit yet, we're going to stop accepting responses, or else people might just copy and paste their responses again, or type in the response I'm typing in. So we're going to lock that quiz. So what this function will do is this will just return the nth value of the Fibonacci sequence. So we're going to return fib of n minus 1 plus fib of n minus 2. Okay, so now if I run this program like this, so print, and then fib of, and maybe like int of input like that. So now if I type in a number, it will give me that number in the Fibonacci sequence. I'll save it, call it Fibo, like that. So if I type in like 10, it should give me the 10th number in the Fibonacci sequence, which is 55. Or I could just you know, just to show you that this works, I'm going to say for I in range 10 to print out the first 10 numbers of the Fibonacci sequence, like that. So this should print out the first 10 numbers. So we have 0, and then 1, 1, 2, 3, 5, 8. So 0 plus 1. So 0 and 1, the reason these were our base cases was because the first numbers in the Fibonacci sequence are 0 and 1. And then the rest of the numbers are just the previous two numbers added together. So that's why we were able to say return fib of n minus 1, so the previous number in the sequence, plus fib of n minus 2, so the previous number before that. So the previous two numbers. And then that's going to be what will return for the nth number. So that's how we calculated this. And then to calculate the sum of all of these, of the nth number, because remember the question was asking to find the sum. So that takes a number n, and returns the sum of the first n numbers in the Fibonacci sequence. So for full credit, you should have found the sum. And remember, I said you could use helper methods. So let's create a method that will be a helper method. Maybe we could call it like sum, or s, call it s. And then s takes in a number n, and then let's create a variable called sum. Sum is equal to 0. And then for I in range, n, sum plus equals we could say sum plus equals fib of I, like that. And then we could print out the sum if we wanted to, like this. Okay, so let's now call this function to show you that it works. So let's say s of, maybe if we wanted to find the sum of the first 3 numbers in the Fibonacci sequence, call s of 3, it says 2. To verify that, let's look at this. First 3 numbers, 0, 1, 1, and the sum of these first 3 numbers is 2. If we wanted to find the sum of the first 4 numbers, we could do this. First 4 numbers, like that, 4. Yep, the first 4 numbers, the sum of the first 4 numbers is 4. I could go on and do maybe like 6 if I wanted to. We get 12. First 6 numbers is 12. Yep. So this is how you could solve this problem recursively. But there is also another way to solve it, what we call iteratively, which is just using a loop instead. So in case you didn't want to use recursion, there was a way. In case you're curious, you could do this iteratively without using recursion. So how we could do this is we could use a list. So let's say I'm creating a list and I'm saying the first values of the list is 0 and 1. And then for I in range, and then since we already have the first 2 values of the Fibonacci sequence, let's start at 2 and let's end at n. Okay, so like that. And then we can say l.append, and then we would just append the values of L of I minus 2 plus L of I minus 1, like this. And then if I print it out L like this, this should give me a list with the Fibonacci sequence in it. So if I set 8, it should give me the first 8 numbers in the Fibonacci sequence. So here are these numbers, and if I compare it to this, they are the same, like that. And then remember, if I wanted to find the sum of a list, I could just type in sum, and then L, and this would give me the sum of the list, like that. So now it's going to print out the sum of the first 8 numbers in the Fibonacci sequence. Okay, so that wraps up our class. Thank you for coming. Be sure to come next time and answer the questions on the quiz. We'll be grading the challenge, the responses for the challenge. So, continue working on your final project. It will give you a lot of points and help determine if you will receive a certificate. So thanks for coming. See you next week. Bye.